Right, how are you guys? I'm just reteaching my chapter 1 because I still remember that the bimester guy did not find the chance to attend to our introductory lesson. So apologies, I'm teaching it after a long time. I've been too busy. So our introduction was mainly on the discussion of what an operating system is and what's its major functions. So you can see this is what we discussed on last time when we introduced the operating system. What operating systems do, maybe it determines the definition of an operating system. Then computer system organization is simply being there to actually show you how a computer works and actually the position of an operating system within the whole computer system. Remember, the whole computer system is composed of hardware, system software, application software. Then maybe the users themselves can be part of the computer system, but they are not the center right now. We want to talk about operating systems and their position and their main functions within a computer, right? So the major functions, you are seeing them: resource management, security protection, virtualization, in distributed systems, of course, to make those systems run, and so on and so forth. Of course, to talk about open source operating systems, maybe versus proprietary operating systems. Those are just issues of how we can own operating systems and use them. But generally, resource management, security, application management, virtualization, those are the major functions of operating systems. Protection during offline and online circumstances and so on and so forth. So you can say an operating system acts as an intermediary between the user of a computer and the hardware. What does that mean? It means most of the applications that we use on a computer do not access or command hardware directly, but they go through an operating system. And each and every operating system, when it is being created, there are goals that are set down when creating an operating system, right? So for example, to execute user programs and make solving problems easier, right? So when you are creating an application for a computer, you don't need to think about how it is going to access hardware, because that's the task of an operating system. To make a computer convenient to use, you can think of a Windows system, right? Then to make hardware be utilized in an efficient way, you shall see that, right? So a computer can be divided into four main components, which are the hardware, which provide the basic computing resources. Then like the CPU, the memory, input devices. Then the operating system, which controls and coordinates the use of hardware among various applications, right? Then the application programs or user programs that define the way in which system resources are used to solve computing problems of users, right? Like word processors, compilers, web browsers, database management system, video games, etc. This is just a small list of user programs. Then of course a computer system cannot work without including users. That is the people that use the computers, the other machines and other computers. They are all part of the computer system. Of course, at the moment they are not very much important because our focus is on operating systems. So look at the three-level architecture of a computer system, right? Where we have application programs or user applications. Then we have an operating system which lies between the operating system and the hardware. And the hardware itself, which then does work, the CPU, the memory, input and output devices, storage devices, and other necessary devices that we may use to actually run a computer. So look at the position of the operating system. It actually means that user programs do not directly interact with the hardware per se, but they go via the operating system, which then facilitates all the operations within the machine of a computer, right? So what are the major functions of operating system, right? So this is the great question. So if we say what are the major functions or what are the core components of operating system, of course we have got major ones, but operating systems are not exactly the same. You cannot imagine a Linux being exactly the same as Windows, or Windows being exactly the same as Android. Look at examples of operating systems that we are giving, and the environments in which they work or they are considered best suitable. They are very different. So the point of view of what an operating system is depends on the kind of operating system that you use. All the users, or what the users want, are the convenience, the performance, maybe the rate at which, the efficiency at which resources are being utilized, right? Some computers, such as mainframes, are shared, right? So it actually means the goal of such an operating system in a shared computer system is to facilitate many users working together, right? Generally, look at the definition there to say we can consider an operating system as a resource allocator and a control program, making efficient use of hardware and managing the execution of user applications, right? This is the general definition. Users dedicate systems such as workstations, users of dedicated systems such as workstations have got dedicated resources, but frequently use shared resources on servers. So you see, it actually means the server will be having an operating system, the dedicated computer will be having an operating system. Each operating system serving maybe slightly different needs. Therefore, such operating systems needs to be slightly different in the way they are made. So we also find operating systems in mobile devices, smartphones, tablets, right, which have got very small resources, small memories, small RAMs, small processors, and we should have operating systems like the Android, which is optimized for such small gadgets, right? So all those are kinds of operating system, but generally the purpose of the operating system is to allocate hardware resources to applications and to control the way applications run, right? So OS may cover many roles because of a myriad designs of operating systems. So whereas we've said an operating system is generally a resource allocator and a control program that controls application, it allocates resources, that is the hardware, the RAM, the CPU, input and output devices. All those things are made available to user applications by the operating system. At the same time, it controls user applications. So because we use operating system in myriad and varied circumstances, it actually means we need different kinds of operating system in each and every circumstance. So that's the goals of making operating system may differ depending on the kind of operating system, because remember, some operating systems are going to be used in networked or distributed systems, some are going to be used by servers, some are going to be used by smartphones, some are going to be used by tablets, personal computers, and so on and so forth. Some are also going to be used by TVs and other small gadgets that have very small operating systems. So an operating system was born when fixed use of computers, computers were more used for military purposes, and the use was generally general, right? But now, because computers are now being used in various fields in the real world, you find we need to have operating systems differing depending on the environment in which we are using the computer. So this leads to the fact that we may not have a generally accepted definition of what an operating system is. You can summarily say an operating system to me is what the vendor has shipped to me, what I have bought from the operating system vendor is what I call the operating system, because each operating system shall be different and they vary widely depending on circumstances in which we use them. Although we have common functions like utilization of resources and control of user applications, but you find operating systems are very big and they've got varied components that are within them, depending on the environment in which they are going to be used and the goals for which each and every operating system was formulated. So everything else on a computer is either a system program which is being shipped within the operating system, or an application program which is installed after the operating system has been installed, and then it is controlled by the operating system. So today's operating systems for general purpose and mobile computing also include middleware, a set of software frameworks that provide additional services to the application developers, such as databases, multimedia, graphics, etc. So you see, the actual definition of an operating system can be very difficult to come by, because the functions of an operating system are so many and varied depending on the operating system that we are talking about. So look at the general structure of a computer. To say a computer can have a hard disk, a CPU, a hard disk, a USB, graphics adapter, memory, and so on and so forth. And you see each of them having some kind of drivers that are found within the operating system to be for the CPU to be able to communicate with all those devices. Right? So how does an operating system in a computer operate? We have input-output devices and the CPU that can actually execute concurrently, right? Each device controller is in charge of a particular device type, right? So it actually means operating system is several device controllers depending on the hardware that we are going to actually use. So a device controller means a hardware controller, right? A mouse is a controller, a screen is a controller, a flash is a controller, anything that you can attach to a computer is a specified device driver that acts as a controller of that, right? So each controller is a local buffer. It means a local buffer means a storage location where data and instructions about that device are stored. So each device controller is an operating system device driver to manage it. A CPU moves from to main memory to and from the local buffer of the device controllers, right? So input and output is from the device or local buffer or controller, right? So a device controller informs the CPU that it has finished an operation by causing an interrupt, right? So you see, it is the basis for communication between the actual computer. Remember, when we are talking about a computer, we are talking about the CPU. So even the hard disk is not part of the CPU. It's an external device to the CPU. Therefore, it needs a controller and some algorithms that are going to be used to control it. So after input-output starts, control returns to the program only upon I/O completion. Wait instruction idles the CPU until the next instruction is executed. A wait loop or condition for memory is being used to do the waiting then. So at most one input or output request is outstanding at a time. No simultaneous output input operation that can take place. But what can happen simultaneously is the running of the CPU and the running of input and output devices, right? So after input-output starts, control returns to the user program without waiting for I/O implementation. So a system call is a request to the OS to allow the user to wait for input or output completion. Then device status table contains an entry for each input-output devices indicating its type, address, and state. So OS indexes into input-output devices table to determine the device status and to modify the table entry to include interrupts. An operating system is responsible for booting or starting the computer, right? There is there is a short program stored in the ROM or EEPROM of a computer, generally known as FOIMON, which is responsible for starting a computer, right? So it actually means if you are starting a computer, you are taking the operating system from the hard disk and placing it into the memory so that it can accept other applications and run them. So an operating system is the basic initializer of a computer for it to start working. So it loads the kernel or the heart of the operating system into the memory and into the processor so that the computer can begin to accept other applications and make them run. So look at the relationship between various parts of a computer and how a modern computer works. Look at the thread that is executing there, and look at the instructions and data movements from the memory, right? Look at input-output of frequent input-output request by various programs, then the data, then some interrupts, then devices. Look at how a modern computer is organized. So to bootstrap simply means to start, to initialize, or to load the basic part of the operating system into the computer so that it starts running. So a kernel simply means the heart of an operating system, the core part of an operating system that does the basic functions. That's what we mean by the kernel, right? So hardware interrupts, like we've said, are ways of communicating between the hardware and the software. We shall get into detail with those. Software that can be run by a computer, since they are controlled by the operating system, they can also have errors, and the errors can be managed by the operating system. There are various problems that the operating system can solve in a computer. For example, infinite loops, failure to access files, and so on and so forth. Now we are talking about types of operating systems, the batch system or single user, or we can say a job-based operating system. That's one type of an operating system where jobs are fed and then the computer executes jobs in the order in which they've been fed into the operating system. Then we come to the multitasking or time sharing. Remember, the batch operating system used to do only one job at a time, and unless the job has been completed, you won't be able to stop it, or you won't be able to instruct it to execute another job. That was the problem of a batch or old system of a computer. Now we have a multitasking computer which is able to run more than one job at a time through time sharing. Jobs are being interleaved within the same CPU. That's the beginning of a simple modern computer, where imagine a computer where we have a single CPU, and jobs are, it is able to run many jobs, unlike the batch system which used to run a single job until it gets through. With the modern computer, we must be able to run many jobs as they are being interleaved. The computer should have a queue of jobs that can be executed concurrently through time sharing of the processor and the RAM. So this is a logical extension of the RAM. The CPU switches jobs so frequently that users interact with each job while it is running, creating an interactive computing, right? When you are using a PC with a single processor, you may think that it has many processors because of the speed in which it shifts from one job to another. So that is the advantage of the modern computer. Even if it has a single processor, it should be able to run many jobs. Look at a multi-programming system. In the RAM of the computer, look, we have an operating system and we have 1, 2, 3, 4 processes that are running. They are not running concurrently. We shall talk about concurrency. Here, they are being interleaved. They are running one after another. When one job is running, others are stopped. Now we come to dual mode operating system that allows to protect itself and other system components. Look, it can have threads run in user mode or in kernel mode. When we are simply saying user mode, we are simply saying control is being relegated to the user application. But when we are saying kernel mode, we are simply saying control is relegated to the core of the operating system. Right? So this is how a computer runs. A modern computer can choose to run in a dual mode. To run in dual mode, to say at one point in time it is giving control to the user application or to the user mode. In the second, on some other time, it is now using the kernel mode or the heart of the operating system. So look at what is happening there. We are having a user process that is controlling. Then there comes a time when the operating system is controlled in the kernel mode. Then the application goes back to the user mode. So the other main function of an operating system is process management. Like we said, to say a user application, when it is running from the eyes of the computer, a user application is called a process. Because when it is running, it is placed in a memory data structure which is called a process control block. So we shall talk about this in detail in other lessons. Otherwise, here what we simply need to know is that process management is one of the major tasks that a computer can do. So process management activities, we've just summarized them there, but actually we shall go into the actual business of doing process management. Otherwise, I'm not going to read them one by one and explain them, because we shall get into the actual topic of process management where we'll deal with this. Then another major task of a computer is memory management. In other words, we are talking about the RAM. Don't mix between the RAM and the disk. When we are talking about memory management, we are talking about the RAM. But when we are talking about the disk and mass storage, we are now talking about storage management. So separate between memory management and storage management in your concept of understanding how a computer works. Because storage management is managing the back storage, whereas memory management is managing the actually running applications and data. Then we go to managing of files within a computer. This is another very important activity that the operating system does. I'm also not going to explain it in detail, but you shall see this as we go on, or you saw them when you were explaining in your groups. So look, we are now coming to mass storage management. This is now disk management. Caching is the main function of the operating system. You should understand what we mean by caching, and this enables computer to utilize the resources or the CPU more efficiently and more fastly, so that it can adapt to high demands. Then we have the input-output subsystem as being another function of the operating system. Then we come to protection and security. When we are talking about protection and security, we are simply talking about logging in, logging out, network protection, antiviruses, making the computer available to the user, to the authorized users, and so on and so forth. Then virtualization. Virtualization is another aspect of memory management that we shall talk about separately. And then we talk about visualization in the concept of the operating system being able to run another operating system within the same computer. So generally, guys, this is what I wanted to talk to you about. I'm just reintroducing the first chapter, so that our bimester student who is in here can actually benefit And I don't think it's a problem for you who were in our introductory lesson when we started the semester. You can also revisit this lecture that I'm making here so that you understand or remember the concepts before you get into the examination. Thank you very much. I'll come back with process management. I know the other topics we did them in the class and we shared the material, but I'm thinking that there are some other areas of process management, there are some other areas of memory management that I should come back to you to explain in detail so that you will be able to prepare for your examinations. Thank you very much.